8-bit microcontroller die? Brandon thought they'd phased out 10 years ago, while Rich questions how many 8-bit MCUs are even still around. The answer? A lot. In this edition of the Embedded Insiders, Brandon and Rich discuss factors and use cases that have kept the 8-bit MCU alive much longer than anyone expected. After, Brandon is joined by Steve Kennelly, 8-bit business unit manager at Microchip Technologies, to continue the discussion. Surprisingly, the company is still developing new, low-cost, low-power 8-bit MCUs. But why? And how long will that market continue to hold? Finally, in this week's Tech Market Madness, Perry investigates how the COVID-19 pandemic affected supply chains in the electronic component market, sourcing industry data from SupplyFrame that suggests technology procurement is headed for a self-service, e-commerce, Amazon-like model. Stay tuned to learn what's been happening in these markets and what you can expect in the future.
Hello and welcome to another edition of the Embedded Insiders. I'm Brandon Lewis, Editor-in-Chief of Embedding Computing Design, and I'm here with Rich Nass, who's the Executive Vice President and Brand Director of the same platform. How you doing, Rich?
Okay, I don't like the term brand director.
I don't either.
Yeah.
I don't like the term Rich Nass.
You got to talk to my parents about that one. But anyway, how you doing, Brandon?
I'm fine. So it is 2021, and did you know that decades, centuries, millennia do not begin with the 00 year? They begin with the 01 year, or the 1 year. So technically, we are now in the 2020s. We are now in the decade of the 2020s.
No, that's actually inaccurate. It starts with the 0.
No, it starts with the 01. I'm serious. It's like 2000 was not the beginning of the new millennium. 2001 was.
Yeah, I guess you're right, because the first year wasn't 0. The first year was 1. So,
yes.
Okay. All right, I'll buy that.
So that being said, us being in a new decade, when are 8-bit microcontrollers going to die?
Well, I actually predicted in 2017 that was the end of 8-bit microcontrollers. You mean they're still around?
I think, when did I start working in the industry? 2010? I think I predicted in 2011 that was the end of 8-bit microcontrollers. Yeah, they are still around, and really it's a lot of cool tricks of architecture mixed in with just way more demand for this tiny bit of intelligence than I think anybody really gave us credit for, or gave the world credit for. As you start thinking about IoT in a lot of sense, we love to speak about, we're going to put AI algorithms out of the edge, or we're going to do all of this edge computing, and we're going to do some really intelligent things. But there's a lot you can do with a little bit of intelligence, and you don't need a 32-bit processor in a light bulb, or even necessarily in your fridge, or in a lot of cases. There are just so many use cases that aren't as sexy, but they fly under the radar.
But if I could do 32 bits for 39 cents, that's not good enough?
Well, how much does your light bulb cost? You want to add another quarter to the cost of a light bulb?
Well, if it has an 8-bit microcontroller in it, it's doing something digital. Mm-hmm. So what is it doing that I can't gain from an extra quarter that would make it significantly better? But
let's turn the question around. What would you do with your light bulb for an extra quarter with a 32-bit micro in it?
Well,
what's your light bulb gonna sing a song?
That opens up Pandora's box, because I actually, whenever a light bulb blows in my house, it gets replaced with a smart bulb, which is way more than a quarter. I just got one for the front entryway of my house that it's a spotlight type bulb. And I think it was $12, which I was actually really impressed. It's only $12. It's a multicolor Wi-Fi bulb that works with my my Echo device. So I can make it go any color I want, anytime I want. And I think it's pretty cool.
$12.
But you're not going to do that with an 8-bit microcontroller.
Well, we all know, you're right. We all know that over at Discotech NAS, those types of appliances are required, but
It's
not here.
it's the funniest thing. Now, I think I might even said this on a prior podcast. When the internet goes down in our house, we have big problems here. You know, we're not able to turn lights on and off. We're not able to open up doors. We're not able to do lots of stuff. It becomes a pretty big problem.
And even an 8-bit micro wouldn't save you from that.
That is correct. That is correct. But I bet the folks at Microchip can explain to us why 8-bit microcontrollers are still going to be here for some time to come.
That's true.
Now, Brandon is joined by Steve Kennelly, the 8-bit business unit manager at Microchip Technologies.
So, Steve, it seems as though the further and further we get forward into the evolution of computing, the more old becomes new again. It's like you're still shipping 8-bit microcontrollers. I mean, how much of a market is there out there for that?
Well, actually, just a slight correction. We're not only still shipping 8-bit microcontrollers, we're still introducing many new 8-bit microcontrollers every year. And that mainly is because the market, everybody talks about the market shifting and things are changing, and that's one of the reasons why people are surprised that 8-bit is still going strong. But one of the shifts that continues to happen is there are more things that it makes sense to put a little bit of computing power into. And an 8-bit micro is perfect for many of those things. If you think about where IoT is going with the edge is really where the most things are, and that's where you can really benefit from a moderate amount of computing power connected to sensors that are then communicating back to some central location in order to do, you name it, from farming to factory automation to maintenance.
So, obviously where people are introducing 64-bit processors, and I started thinking, wow, think about all these applications you can run on it. 8-bit is not that realm. But there are obvious things you can do there. However, what do you get out of an 8-bit? I mean, are you just talking about, okay, yeah, turn the light on, turn the light off?
Turning lights on and off is one of the big things that we do, actually, or actually that our customers use our parts for. Not only turning them on and off, but also driving them. So power conversion, all kinds of sensing, all kinds of control, all kinds of pre-processing of sensor data that needs to be analyzed by a much more powerful processor. But if you can do a couple of steps before it gets there, it can make everything more efficient. There are still a ton of finished things that fit very nicely in an 8-bit processor's realm. You think about, you could make a thermostat that has an 8-bit micro, that also has the touch interface for the user, that also has an LCD driver. So you can put the whole thermostat into an 8-bit MCU with almost nothing else in there. You could also make a thermostat that is maybe a Raspberry Pi or a larger 32-bit system that needs to do some peripheral functions, that has other functions that need to be done, that can be handled more efficiently by an 8-bit micro. One that we just heard of, there's a company that's making rapid testers to detect different viruses. And that is using a 32-bit micro along with a number of 8-bit micros to control things like heaters and excitation lamps and sensors. So along with the big micro, there are a number of smaller micros that are doing specific functions within that system. And those are the kind of things that are really driving the evolution and the adoption rate of 8-bit microcontrollers. And I think will continue for some time.
It's funny you say that 32 bits are the big micros.
Right.
So with that 8 bits out there, doing some pre-processing, you mentioned, what is that pre-processing? I mean, I would imagine that you're using them in a lot of cases to do some initial signal processing, but with only 8 bits, how effective can that be?
So you may be translating, right? And pre-processing may mean being connected to a sensor that uses an analog output, a 0 to 5 volt or a 0 to 1 volt output. And that needs to go into another processor that's expecting a 16-bit digital word. And so if you can incorporate into the sensor the processing capability to do the analog to digital conversion, maybe after doing some filtering, maybe after doing some amplification, maybe after doing some other signal conditioning out there at the actual node, and then convert that to a digital format in the correct format that's expected by the OS that's on the other side, and then move that data over whatever communications protocol is required for that particular case. That can simplify a lot of things instead of moving an analog signal a great distance and having to deal with the losses and the noise and everything else that comes along with that. So those are the kinds of applications that that we see the 8 bits doing pre-processing of some sensor data.
So let's take a sort of a drill down. I mean, you just looked at the signal chain from a broader system level perspective, but what's happening actually in the 8-bit? I mean, because you're talking about low cost and low power. These are the reasons that you would use an 8-bit, but there's got to be something more complex going on underneath the hood in order to allow that small of a piece of logic to accomplish some of the things you just talked about.
So within I think what you're getting at is how is it that an 8-bit MCU is able to do anything that's really significant in terms of the pre-processing or getting work done. And one way that we've done that is by architecting the peripherals that go onto that MCU and how they're connected to the bus to other peripherals on the MCU. So it's possible on a new 8-bit MCU to have the CPU maybe doing lookups and things that are fairly time intensive, that take a lot of cycles. At the same time, an A to D converter is taking successive readings of an analog signal, coming up with an average, comparing that to thresholds, and storing it into a table in memory where it's going to be pulled out by a SPI port that's using a DMA as soon as that memory buffer is full. So you can have maybe 3 different functions simultaneously executing on an 8-bit MCU in addition to what the core is doing to oversee everything, or possibly doing some more math-intensive functions.
And so those functions that you just mentioned with the ADC, that's completely independent of the CPU, and therefore, would you be able to do something like just bypass that additional 8-bit CPU altogether, and just if necessary for whatever reason, just pipe it back up to the bigger 32-bit?
Well, we have people that do precisely that. Yes, we've seen customers make use of these peripherals to do just that kind of thing. And in fact, we've some of our processor families were kind of aimed at that sort of application. We've put some heavier analog functionality on processors in the past, like op amps and specialized PWMs, so that you can actually create a power conversion system. So you can make a voltage regulator, say for driving LEDs. And once the CPU writes all the registers and gets everything configured, it can go to sleep and the whole application is running just on the peripherals while the CPU is resting, unless something comes up that it has to do, maybe to change some parameters, because you're going from a string of 3 LEDs to 7 now, so you've got to reconfigure the power supply, and you can do that dynamically.
Wow. So I mean, I know that Microchip has been working on a lot of this type of functionality in the PIC line of microcontrollers for some time, but since then you've acquired several different organizations. So where is this sort of core independent peripheral, this sort of, you know, isolated analog functionality that comes with a CPU that you may or may not use? Where else has that been distributed throughout your portfolio?
Well, certainly we're seeing that in the AVR line, the 8-bit AVRs that we're still continuing to bring out new versions of, and as well it's in our 16 and 32-bit MCUs. So pretty much the idea of what we call core independence, having peripherals that can be set up and then operate to perform a certain function autonomously. Tell you the truth, Brandon, I'm not sure where else how far that extends. It's really important on the 8-bit side because we use it as a technique to increase performance, reduce latency, get more real time with, let's face it, an 8-bit core.
Right, for sure.
Right.
So from a programming paradigm perspective, you know, is this something that you need like analog chops to take advantage of, or, you know, are you now saying, okay, well, you know, what you save in the cost for the 8-bit, you're going to spend in having to have like an analog engineer to help you program these on-chip peripherals?
That's actually a really good question, because we have, like I mentioned, put things like op-amps on MCUs in the past, but they were really kind of just a co-packaged component, right? It was an MCU and an op-amp in the same package, and it saved you some space, and you had it available there. What we're doing now with specifically op-amps is we're turning them into peripherals with that same core independent kind of philosophy that we use for our digital peripherals. So they're also part of the IDE, and the part of making an analog component like an op-amp a peripheral is connecting it to the CPU bus. So you've got the op-amp that's in there, and the inputs are connected through multiplexers to almost all of the other analog and many of the digital peripherals on the chip, as well as to external pins. So if I want to use that op-amp with the very same IDE that I'm writing my C code in, the very same IDE that I use to set up all the system configurations of the MCU, I can select that op-amp peripheral. I can choose a configuration, like I want to make a gain amplifier, or I want to make a buffer, or I want to make a instrumentation amplifier, and then I can select what I want to be the inputs and the outputs of that function. So I want the inverting input to come from an internal voltage reference, and I want the non-inverting input to come from this I/O pin, and I want the output to go to the input of the A to D converter or to an external pin, completely configurable. And then I define the parameters like the gain, what's going to trigger it, what's it going to do, is it going to run all the time, or is it going to, only when certain conditions are met. And then I can look at a graphic of the schematic that has been proposed by the system, and then I just push a button, it generates the code, and at runtime all the registers get set up, and now I've got an analog function that's doing exactly what I want it to do using the inputs and outputs that I've specified. So we're really turning the analog components into digital peripherals for the guys that know MCU design but don't want to go learn how to do the heavy lifting of analog design.
Wow, that's fantastic. So just sort of bringing it back around full circle, what's the market doing for you guys? Is it, I mean, are you plateauing in your 8-bit offerings? I mean, you're obviously still investing in this technology, and as you said, you're bringing out new parts even. Or do you see growth here?
Definitely. Yeah, it's continuing to grow, and we're constantly surprised and encouraged at the number of ways that our customers figure out to use our parts. So really what we focus on is creating very versatile, very flexible, very easy to use components in these core independent peripherals that can be put together and configured in different ways to create functions that are specific to each customer's needs and applications. And like I said, I almost want to say, I'm not sure how to say this, but we're really bad at anticipating how many ways customers are going to find to use our parts, because we're constantly surprised at the new things that they come up with.
Well, that's great. Well, Steve, thank you so much for your time. And I just want to highlight 8-bit and analog. Who would have thought?
Together again.
Yeah.
Now it's time for Tech Market Madness. The COVID-19 pandemic disrupted supply chains in every industry, including electronic components. And this disruption wasn't just in the form of slowdowns caused by office closures, hiring freezes, suspended budgets, or factory production coming to a standstill. To hear Richard Barnett, CMO at market intelligence and software as a service platform provider SupplyFrame tell it, the cancellation and postponement of industry events had as big of an impact on the electronic supply chain as any of those things. Here he is citing research compiled from multiple sources, including recent Deloitte and Wunderman Thompson reports.
The most disruptive was, for a lot of the component suppliers and distributors, a shift from no, large, sort of quarterly or annual industry events that may be focused around a specific category or commodity group. We saw that across every industry, but that had a huge disruptive effect because so many component suppliers really relied on those kind of industry event and conferences to really influence their market, kind of announce new product introductions, influence kind of their technical and engineering audiences. That went away, and so did the ability to meet in person. And so, we saw a shift, of buying directly from a sales representative or large account teams. That went down to less than 20%, and it was about 60% on average before what the typical vendor B2B kind of relationship would be between, say, a manufacturer and their distributor or supplier directly.
Obviously, if traditional activity with a sales rep or account team at a distributor has dropped below 20% from the 60% of sales that occurred that way before the pandemic, there is a potentially massive problem with the very beginning of the supply chain, the sale. Or is there? What's been happening? Have orders stopped altogether? Does this mean that engineers are going to have to start jerry-rigging capacitors out of aluminum foil and scrap metal? Or that the end users are headed for a tech desert of dumb light bulbs and stupid Fitbits and Amazon Echo paperweights? Well, according to the Consumer Technology Association, who recently forecasted a 4.3% rise in consumer retail sales in 2021, no, we aren't. That's because the pandemic also appears to have launched electronics procurement professionals into the 21st, or is it 20th, century on the e-commerce platforms. Barnett explains.
Kind of looking at kind of the value chain around electronic components, distributors, contract manufacturers, and kind of large global manufacturing companies, one of the biggest shifts that we saw happening, and this makes sense, is that just a significant overall increase in e-commerce and engagement on either component supplier, semiconductor, or distributors' websites around information related to technical content, and then beginning to do more and more direct e-commerce transactions versus offline transactions, which are still very common around requests for quotes being sent over in email, attachments on Excel spreadsheets.
Citing separate data from research firm McKinsey, Barnett notes that 75% of professionals who have been exposed to this virtual B2B electronic sales environment believe it is at least as effective as the mechanisms used prior to COVID-19 and are very likely to continue conducting business this way.
I think it's a disruption that has accelerated what should be a transformation trend. That just needs to happen. I think that's a good way of framing it. So if you look at, the shifts in e-commerce and digital marketing, digital sort of engagement, customer experience models in adjacent industries, both on B2C as well as in B2B, there are a number of best practices and, successful strategies which have emerged that many of the, kind of suppliers within electronic components, distributors, semiconductor companies can all take advantage of. And I think one of the real issues, the root cause issues, has been for a long time that many of these companies have led through, either the breadth of a product catalog or, the quality and the sort of, the technical capabilities of a set of products, very engineering oriented. And digital maturity has definitely lagged behind. I mean, one of the things I constantly observe is this, deep irony around how digital laggards in the, this broad global electronics component value chain are the ones that are actually, driving, the underlying enablement technology-wise of digital transformations that are occurring across all industries. And, that imbalance needs to kind of get rectified.
Of course, this self-service, Amazon-like model of electronic procurement will also have a direct impact on component suppliers, who will be forced to become more agile and transparent than in the past. As Barnett points out, between 62 and 65% of the purchasing and procurement process is conducted before engaging with a vendor, which makes having inventory readily available at a competitive price more important than the brand or breadth of a catalog. Again, Barnett.
And so the suppliers now need to really think about not just responding to, volume-based purchase trends or just holding inventory as a buffer, or hoping that they've got the best, broadest catalog so buyers come to them. But to be the supplier of choice in the future, it's going to be a combination of providing and then having greater transparency of lead time, inventory, and price, even that of their competitors at the point of purchase or the point of sourcing decisions.
So, does all this signal the proverbial death of the electronic component salesman? Not exactly.
And what that's triggered is for a few of our customers, a kind of an internal transformation initiative that got accelerated around building, sort of centralized or regionalized inside sales teams that, are also what you might call demand centers. They kind of support both existing customer support requests and technical information requests, as well as handling new opportunities across a segment of their customer markets. And, the companies that are investing in accelerating those transitions, even if they had like a, short-term, decrease in revenue, are really poised to benefit the most as we see the turnaround in the recovery post the pandemic.
Thanks for listening to this edition of Embedded Insiders. For daily industry news, videos, and podcasts, visit our website, embeddedcomputing.com.